Visualization for explainable and trustworthy machine learning remains one of the most important and heavily researched fields within information visualization and visual analytics, with various applications domains, such as medicine, finance, and bioinformatics. After our 2020 state-of-the-art report comprising 200 techniques, we have persistently collected peer-reviewed articles describing visualization techniques, categorized them based on the previously established categorization schema consisting of 119 categories, and provided the resulting collection of 542 techniques in an online survey browser available at trustmlvs.lnu.sc. This figure shows the temporal distribution of our collection of 542 publications, with a remarkable increase evident in 2021 and another significant rise in numbers for 2023. We have also performed a co-authorship analysis in Gephi, weighting author nodes by their number of co-authorship edges. The network has 96 weakly connected components, with 10 largest clusters color-coded. A dominant blue cluster accounts for approximately 70% of all network connections, compared to around 41% in the 2020 state-of-the-art report. Although the highlighted industry cluster is more connected than in the 2020 state-of-the-art report, it still stands somewhat apart from its academic counterparts, suggesting that increased collaboration between these two sectors may improve the visualization research output. This survey article uses our multi-level model of trust in machine learning that consists of 5 trust levels. Here we discuss important findings for each trust level. For trust level 1, more work tackles source reliability problems rather than the transparent collection process challenge. For trust level 2, researchers focus on the comparison of structures with an increase of 7% prior to the past 3 years, and then outlier detection and guidance. For trust level 3, understanding, steering, debugging, and comparing machine learning methods are quite popular. Understanding became approximately 10% more common recently, and more techniques are designed for debugging than comparing in the past 3 years. For trust level 4, performance, in situ comparison, and what-if hypotheses are commonly emerging categories associated with a concrete machine learning model selection. For trust level 5, metrics validation and results observation is the most frequent category, covering approximately 76% of all the articles. As for evaluating the visualization techniques, there is a huge improvement compared to 3 years before. We have also conducted a topic analysis using latent Dirichlet allocation based on the full text from the PDFs. A common theme in topic 2 is the use of visualization in explaining decision trees, while topic 10 specifically refers to rule-based machine learning models that are successful with tabular data and arguably easier for analysts to understand. Topic 3 focuses mainly on deep learning for image data, with a recent subtopic being federated learning. Another recent trend shown in topic 4 is the employment of transformers for text data, and even extending their use in image applications with the so-called vision transformers. Topic 9 is mainly about text data, but this time with visualization solutions for graph and recurrent neural networks. And finally, topic 5 describes the use of projections for explaining neural network architectures. Clustering projecting points with dimensionality reduction can also be useful for guiding subspace exploration and individual points examination. Our results show the rapidly growing trend of visualization techniques for increasing trust in machine learning models in the past 3 years, with visualization found to help improve popular model explainability methods such as LIME and SAP. Visual inspecting new deep learning architectures like vision transformers and self-supervision are other areas of rapid advancement that require the visualization community's attention, as well as prompt engineering and model checkers for hallucinations of large language models, LLMs. As of recently, most visual analytics solutions were arguably focusing on exploratory visual analysis. However, there is a trend in utilizing visual representations for confirmatory analysis, hypothesis testing, and causal reasoning. For example, counterfactual reasoning, causal learning, and causal inference could be enhanced by visualizations. While uncertainty quantification and sensitivity analysis are popular in other fields, visualization research is still limited in checking the inputs and outputs of models, such as with a conformal prediction method that provides statistical guarantees. Please check our survey article for more open challenges and further insights that were extracted from additional analyses such as temporal correlation and advanced pattern analysis. Thank you for watching.